Imagine, for a moment, a colossal explosion erupting on the surface of the sun. An event so powerful, it releases more energy in a few minutes than all the power plants on Earth could generate in thousands of years. This fiery burst of energy, known as a solar flare, is so immense that it makes our entire planet look tiny by comparison, almost like a speck of dust floating in the vastness of space. But this isn't the stuff of science fiction or distant galaxies. This is space weather, a real and dynamic force that shapes our solar system every single day. Occasionally, the sun unleashes not just solar flares but also massive clouds of charged particles called coronal mass ejections, or CMEs. These eruptions can be so large they stretch millions of kilometers into space, carrying with them intense magnetic fields and radiation. When these solar storms occur, they send a relentless stream of charged particles, known as the solar wind, racing across the solar system at speeds of up to several million kilometers per hour, sometimes heading straight for Earth. It's natural to feel a bit uneasy about these powerful outbursts from our star. After all, they have the potential to disrupt satellites, interfere with radio communications, and even cause power outages here on Earth. But there's no need for panic. Our planet is equipped with its own invisible shield, the magnetic field, which acts as a protective barrier, deflecting most of these harmful particles and keeping us safe from the sun's most dangerous tantrums. In fact, when these solar particles interact with our magnetic field, they create one of nature's most spectacular light shows, the auroras, or northern and southern lights, painting the sky with vibrant colors and reminding us of the sun's incredible power. Scientists around the world dedicate their lives to studying space weather, using advanced telescopes and satellites to monitor the sun's activity and predict when these solar storms might occur. By understanding the sun's behavior, we can develop better technology and strategies to protect our power grids, satellites, and even astronauts living and working in space, ensuring that our modern way of life remains uninterrupted. Space weather is a constant reminder that we are part of a much larger, ever-changing universe, one filled with beauty, mystery, and forces beyond our everyday experience. So buckle up and get ready to embark on a journey through the thrilling world of space weather, where science, wonder, and the power of the cosmos all come together. So, what exactly is space weather? You might have heard the term before, but it's not about rain or sunshine in space. Instead, space weather refers to the ever-changing environmental conditions in the region of space surrounding our planet, driven by the activity of the sun. Just like weather on Earth, space weather describes the constantly changing conditions in space. But instead of clouds, wind, and rain, we're talking about streams of charged particles, bursts of radiation, and magnetic fields that can shift in an instant. These changes can have real effects on our planet and the technology we rely on every day. It's all thanks to our very own star, the sun. The sun is not just a source of light and warmth. It's a dynamic, powerful engine that constantly shapes the space environment around us. The sun is a giant ball of hot gas that's constantly buzzing with activity. Its surface is a boiling, churning sea of plasma, with magnetic fields twisting and snapping, creating dramatic and sometimes violent events. This activity can result in explosions called solar flares, which release huge amounts of energy in the form of light and radiation. Solar flares are like massive bursts of energy, sometimes many times more powerful than all the energy produced on Earth at any given moment. Sometimes, these explosions also launch giant clouds of solar material called coronal mass ejections, or CMEs, into space. These CMEs are enormous bubbles of electrified gas and magnetic fields, and when they erupt, they can travel millions of miles through the solar system. In addition to flares and CMEs, the sun constantly emits a stream of charged particles known as the solar wind. This solar wind flows outward in all directions, carrying energy and magnetic fields across the solar system and shaping the space weather environment around every planet, including Earth. These solar flares and CMEs can travel through space at incredible speeds, and if they're aimed towards Earth, they can interact with our planet's magnetic field and atmosphere. When these energetic particles and magnetic fields reach Earth, they can trigger a chain reaction of effects, both beautiful and potentially hazardous. This interaction can cause a variety of effects, from beautiful auroras, those shimmering lights in the polar skies, to disruptions in our technology. Space weather can interfere with satellite communications, GPS signals, and even cause power outages by affecting electrical grids on the ground. Understanding the different components of space weather like solar flares, CMEs, and their potential impacts helps us appreciate the dynamic relationship between the sun and Earth. By studying space weather, scientists can better predict and prepare for its effects, protecting our technology and deepening our understanding of the universe we live in. Space weather might sound like something out of a science fiction movie, conjuring up images of distant galaxies, alien worlds, and cosmic storms swirling far beyond our reach. But the truth is, space weather is very real, and its effects can be surprisingly close to home, sometimes even right outside your window. While we often think of weather as something that happens in the atmosphere above us, space weather refers to the powerful bursts of energy and particles that the sun sends our way. These invisible forces can create dazzling displays like the northern lights, but they can also disrupt our daily lives in ways most people never imagine. One of the most famous examples of this happened in 1989 when a powerful coronal mass ejection, or CME, slammed into Earth's magnetic field. The result? A massive blackout that swept across the Canadian province of Quebec, plunging millions of people into darkness in a matter of seconds. For some, the blackout lasted up to 9 hours. Imagine entire neighborhoods, cities, and towns suddenly losing power. No lights, no heat, and no way to communicate except by candlelight or battery-powered radios. It was a stark reminder of how much we depend on electricity, and how quickly it can all be taken away by forces from space. And that wasn't the only time space weather caused chaos. In 2003, a series of intense solar flares and CMEs triggered radio blackouts, disrupted satellite communications, and even forced airlines to reroute flights over the polar regions to avoid losing contact with air traffic control. For hours, pilots and ground crews scrambled to adapt, highlighting just how vulnerable our modern systems are to solar storms. Today, our world is more connected than ever before. Offices, homes, hospitals, and entire cities rely on a constant flow of electricity and data. From smartphones and laptops to massive data centers that power the internet, our daily routines depend on technology that can be disrupted in an instant by a strong solar event. Satellites orbiting high above Earth are especially at risk. They provide us with GPS navigation, weather forecasts, television signals, and global communications. A single powerful solar storm could knock out these vital services, affecting everything from emergency response to your ability to find directions on your phone. So, as we marvel at our technological achievements and gaze up at the stars, it's important to remember that we're still connected to the cosmos in ways both beautiful and unpredictable. Space weather is a powerful force, reminding us that even in our high-tech world, we remain at the mercy of nature's grand design, sometimes in ways we least expect. Thankfully, Earth isn't defenseless against the sun's outbursts. Our planet has two incredible shields that protect us from the worst of space weather: the magnetic field and the atmosphere. The Earth's magnetic field acts like a giant shield, deflecting most of the charged particles from the sun away from our planet. This invisible force field, generated deep within the Earth's core, extends far out into space, forming a protective bubble around us. But it's not just the magnetic field that keeps us safe. Our atmosphere, a delicate layer of gases surrounding Earth, also plays a crucial role. It absorbs the sun's harmful radiation, preventing it from reaching the surface and harming life. Together, the magnetic field and atmosphere act like a superhero duo, protecting us from the sun's fiery temper tantrums. While space weather can be disruptive, it can also be, honestly, incredibly beautiful. One of the most stunning displays of this is the aurora borealis, or northern lights, in the northern hemisphere, and the aurora australis, or southern lights, in the southern hemisphere. These mesmerizing displays of light and color dancing across the night sky are actually a direct result of space weather. When charged particles from the sun collide with atoms in Earth's atmosphere, they excite these atoms, causing them to release energy in the form of light. This light creates the vibrant greens, reds, blues, and purples that really characterize the auroras. They are a breathtaking reminder of the powerful forces at play in our solar system and the interconnectedness between Earth and the sun. Imagine a major solar storm hitting Earth today. What would happen? Well, the most immediate effect would likely be widespread disruptions to our technology. Satellites could be damaged or even knocked offline, disrupting GPS systems, communication networks, and television broadcasts. Power grids could experience surges, leading to blackouts like the one in 1989, but potentially on a much larger scale. Air travel would also be affected, with planes forced to reroute away from polar regions where radiation levels would be highest. While it sounds scary, it's important to remember that scientists are constantly monitoring the sun, and can often provide warnings before a major solar storm hits. This gives us time to prepare and mitigate the potential impacts. We're not flying blind when it comes to space weather. Scientists around the world are constantly monitoring the sun, keeping a watchful eye out for any signs of potential solar storms. They use a fleet of spacecraft and ground-based telescopes to observe the sun 24/7, tracking sunspots, solar flares, and coronal mass ejections. Just like meteorologists use satellites and weather stations to predict weather patterns on Earth, space weather forecasters use data from these observatories to predict solar storms. While we can't stop a solar storm from happening, we can use these predictions to prepare and minimize disruptions. It's easy to feel a little vulnerable knowing that Earth is constantly bombarded by radiation and charged particles from the sun, but it's important to remember that severe space weather events are relatively rare. Our planet has weathered countless solar storms throughout its history, and life has thrived. While we should be aware of the potential impacts of space weather, we shouldn't let it make us afraid of exploring the universe. Instead, let it fuel our curiosity. The more we learn about space weather, the better equipped we'll be to protect our technology and continue our journey of discovery. As we venture further into the cosmos, understanding space weather becomes even more important. Future missions to the Moon, Mars, and beyond will require even more sophisticated space weather forecasting and mitigation strategies to keep our astronauts safe. The study of space weather is a fascinating and evolving field. We're constantly learning new things about the sun and its impact on our planet. So keep looking up at the stars and never stop asking questions about the universe around us. After all, it's our inherent curiosity and thirst for knowledge that will continue to drive us forward, pushing the boundaries of human exploration and understanding.